This is our Precalculus 5th 6 weeks final 2017. This test covers 4 things. It covers elementary vectors, a few problems, law of sines, law of cosines, and parametric equations. So those are the things we've covered this 5th 6 week term. So go over these problems. Number 1, the coordinates of point A are 4, 5, and the coordinates of point B are 9, -3. What is vector AB in component form? What you use for this is something we call the head minus tail, abbreviate that HMT. And what you do is you look for where the vector finishes. You see this little arrow over this B? That means our head, where we finish, is going to be this 0.9, -3, and the tail where we start is going to be 4, 5. So therefore, for head minus tail, we're going to take B minus A, and point B is 9, -3, and point A is 4, 5. And so we'll just subtract. So vector AB in component form, we use angular brackets instead of parentheses. What we do is just subtract. So 9 minus 4 is 5, and -3 minus 5 is -8. So our correct answer for this will be C. Next problem, 2. Vector B is 2, 5. Vector W is -4, -3. If vector P equals 2B minus W, what is vector P in component form? Well, we're going to take 2B. 2B is equal to 2 times vector B, and B is 2, 5. So that's going to be equal to, using distributive property, we have 4, 10. So P equals 2B minus W is equal to this 2B, again we figure that out as 4, 10, and the W is -4, -3. So P equals, we're going to take 4 minus -4, a little integer arithmetic, so we get 8, and then 10 minus -3 will be 13. So that gives us our answer choice C. Okay. Next, what are the 2 characteristics that define a vector? Well, in the class I showed a little clip from Despicable Me where we have the character Vector introducing himself to get a loan from the crime syndicate, and he explains that he is going to use vector because he is committing crimes with both magnitude and direction. Really, that's it. So magnitude and direction is one way to describe a vector, and also component form. Other ways too. Standard unit vectors. We'll get into that later. If you know each of the 3 sides of a triangle, what is the first thing you need to do to start solving for the angles? Well, if you have a triangle like this, okay, we have 8 to 10. We can't use law of sines because we don't have a known side opposite a known angle. We could use Heron's formula with this, but Heron's formula is for area. Pythagorean theorem, we do not have a right angle. It's going to be the law of cosines. You're going to see in this exam later on, I think problem 8 is a situation similar to this. Should be a pretty easy problem. What is the measure of side Q of the triangle PQR shown below? And what you look for is how you solve. So we don't see any right angles, but we see that we have this unknown side Q opposite this known angle 75 degrees, and this known angle 35 degrees opposite this known side of length of 18 meters. Therefore, we can set up an equation to solve this, and we're going to have side Q opposite sine of 75 degrees is equal to, we have 18 meters opposite our sine of 35 degrees. And we can just go to our calculator, which is a TI Nspire CX calculator. And here we are on our calculator page, and I happen to notice that we have degree is up here in the view screen, so we're ready to put this equation in place. I'm going to use a numerical solve, and it's a special feature on the TI Nspire CX calculator. Press menu, 3, 1. We're going to go ahead and press Control Division. We're going to solve for Q over sine of 75 degrees is equal to the known side, which is 18, over the sine of 35 degrees. And we come over here to the right, we press comma, Q, we should get our answer here. 30.3 should be our length here. So we go over here, see if we have an answer. We don't have 30.3. But we certainly, to the nearest meter, have our best answer choice, which is A. Next. Okay, we do not have any, we don't have a known side opposite a known angle, but we have a side angle side situation, which is an application for law of cosines. So in this case, our unknown side is A, so we'll say right after our equation is A squared equals our sides that we know squared, so we got 44 squared plus 22 squared. Now, I hope you notice that right now we have a Pythagorean theorem situation, except we don't have a 90-degree angle here to work with, but a 112-degree angle. So making the adjustment that the law of cosines allows us to make is we put in minus 2 times 44 times 22 times our cosine of our known angle, which is 112 degrees. So we're just going to go into our calculator, and we're going to use numerical solve again. Menu, 3, 1. So we're going to put in A squared, and that's equal to 44 squared plus 22 squared minus 2 times 44 times 22 times the cosine of 112 degrees. And we don't have to put a degree symbol there, and we're going to press comma A. Since we're solving for A, we get 56.08, so about 56.1. So and that's going to be in inches, and our best answer choice is C. Next, 7. Okay, this time we do have a known side opposite a known angle, and we're trying to find angle D. Well, here's angle D, and we have a known side 17 opposite angle D. So we can just go and set up our equation. We have sine of D over side D, which is 17, equal sine of 60 degrees. I happen to remember that's square root of 3 over 2 over 19. And we can go to our calculator again. Menu 3, 1, control, division. We're going to have sine of D over 17, our known side 17, and that's going to be equal to our known angle, or the sine of our known angle, which is 60 degrees, over our known side, which is 19. And we go to press comma D, indicating we're solving for D. We get 50.8 degrees, round the nearest tenth. So D and our answer choice is A. Next, 8. Now this 8 should recall a problem that came up earlier on this test, and it was this one right here, problem 4. Okay, you just have 3 sides, and so we're going to try to find angle C right here. Well, in this case, we have our side C, which is opposite angle C, which is 21. We square that, equals 11 squared plus 15 squared minus 2 times 11 times 15 times cosine C, which we don't know. So without something like numerical solve, we have just more manipulation to do. But we're going to just go to our TI Inspire CX calculator again. Well, I never had anything close to that when I was taking trigonometry back in the day. So we put in our equation, which is 21 squared. Sure that's right. Yeah. Okay, 21 squared equals 11 squared plus 15 squared minus 2 times 11 times 15 times cosine C. We'll put the C here. We'll press comma C. We are observing that we have, again, we're still in degrees, so we get 106.7 degrees. So C that's answer choice B. Next, 9. For the parametric equation, x equals t over 2, y equals t squared, what is the rectangular form of the equation? So if we take this x equals t over 2 and solve for t, and do that if we multiply both sides of this equation by 2, we have 2 over 2 cancel on the right side, and the left side we have 2x is equal to t. So we can take this 2x that we replace with t and put it right up here in place of this t. So we have y equals 2t squared, and if we square the 2, we get 4. Square the t, we get t. We get, I'm putting t there. I misplaced that. I should be putting 2x squared. So that equals 4. 2 squared is 4. X squared is x squared. So y equals 4x squared. That's going to be answer choice C. Now, if you mistakenly don't put this 2x inside parentheses, you might just get 2x squared and end up with answer choice A incorrectly. There's another way to do this. I saw some students struggling, kind of forgetting the whole situation. If you go in your calculator, you can enter this parametric equation and then check which graph best matches. So to do that, if we go to Control I happened to have pre-entered that parametric equation. So to get to parametric equation, go to menu 3-4. I'm going to go up here to this parametric equation I entered, and you get this little half a parabola. We'll get a fuller parabola if we go down for the time element. I'm going to change the 0 here to -5. See if that'll give it to us. No, it didn't here. -5, enter. Okay, there we go. So we get a fuller parabola. And then we could go from here. Now we're still in parametric mode here, but if we go to Control I, we can graph. If we put in 4x squared, we will see the best match, okay, to this other one that we graph. See, you can just kind of flip back and forth and see. So they're the same thing. Okay. Next, 10. Softball pitch is modeled by the parametric equation x equals 85 cosine of 8 degrees t, y equals 3 plus 85 sine 8 degrees t minus 16t squared. Normally I like to have these equations entered in advance to save time, but I want to show a little nuance here about how to enter this degree and how, if you don't enter it properly, you can be in trouble. So I go to Control I, add graph, and we're going to go to menu, graph, parametric, and we're going to put in 85 times cosine and 8 degrees here times t, and come down here. The other one we'll put in y, one we'll put 85 times sine 8 for 8 degrees times t, and we're going to add 3, subtract 16t squared, and I'm going to come down here and change this t step to 0.04, and we should get a graphed equation. We could change our window, but I'm just going to press enter. I just don't see anything here. What has happened? Well, you can kind of see to the left, the thing kind of goes up to the left. So if we go to trace, 5 trace, graph trace, see we're going up to the left. If you go in time, it shouldn't be that at all. We should get a regular just arc going to the right with time. Let me show you what this problem is. You see this radian in the graph pages, the calculator is automatically in radians mode. So what we need to do is give better instructions. So if we go back to this equation entered here, here it is, we have to go ahead with this 8 and put in a degree symbol. So if I do that, we go press the pi key and get that degree symbol. We have to do that here for sine also. So that's something to look out for. If the graph parametric equation doesn't make any sense, check your degrees versus radians and just put a degree symbol. You'll fix things up right. And you press enter, and we get this path to the right. And we can play around with the window, window zoom, and window settings. It's a softball pitch. We can go from -10 to say 70, and then let's see, Y minimum we can start at 0, go up to 10 feet, maybe that'll do it. And so we get a path. And even if we don't set a window, we can automatically go to graph trace. I'm going to go to graph trace right now, but you see our maximum height's going to be right here. So if we go to menu graph, or trace, menu trace, graph trace, and we can just trace in time to the right. And we're getting a maximum height of about 5.19 right now, 5.17. So 5.19 is the highest we see right here. And 5.19 feet is approximately equal to 5.2 feet. So our best answer is C. I want to show again how critical it is to enter that degree symbol. 11. Golf ball struck off the ground level speed of 160 meters per second at an angle of incidence of 65 degrees. What parametric equation best models the situation? Well, the thing you have to remember is that x is the horizontal is associated with cosine, and the vertical is associated with sine. So if you don't see, here you have y equals cosine. No, it's supposed to be x equals cosine. That's wrong. This one here, well, you have b is force of gravity. Well, -16t squared. That has to do with the sine or vertical situation. Choice A, you have sine and cosine, vice versa. And really, it's going to be answer choice D. So this should have been a rather obvious problem. 12. Dallas Cowboys football player Dak Prescott throws the football according to the parametric equation. X equals 80 cosine 40 degrees t. Y equals 80 sine 40 degrees t. Minus 16 squared plus 6 to the nearest foot. How far does the ball travel horizontally before it hits the ground? Mark your answer to be provided. Credit will be given for an answer with 2% correct in either direction from the actual answer. Well, we can go to our calculator and just enter the equation. I'm going to go Control I. In this case, I did pre-enter. I'm going to go to menu 3, 4. And here is that pre-entered equation. I'm going to t-step this down here. I'm going to go to 0.04. Anything kind of defaults automatically if you get that close to 0.031. But anyway, we'll go and graph this, and we see the ball being released. So we can size the window, but if we decide not to size the window, we can just press graph trace and see until we hit ground level and check the horizontal distance. So if we go to menu 5, graph trace, we can just go in time to the right, and it's going by 0.04 seconds, so it's going to take a little while. But here we reach maximum elevation. We'll go past that. So we're looking for the x-axis essentially here as we go down. We should get there soon. There we go. And that's going to be about as close as we can get. So here, at t equals 3.32 seconds, we are just 0.366 feet off the ground, and we are 203 feet away. So that's going to be our best answer. It might be, if we went exactly, probably a little over 203 feet, but that's going to be a pretty correct answer. So we'll put 203 feet, and we just trace that parametrically. So if we go and put in 203 anywhere consecutive. And you can put the plus sign, but that's not necessary. The gridding defaults to plus. So we put 203. And I think in the grading of this, I think the lower limit we accepted, which was 2% variation, would be about 199. And the higher level would be 2% higher, would be 207. So I'm looking for something between 199 and 207 feet, which will give you plenty of leeway. So that's problem 12. Problem 13, vector v in component form is 6, -3. What is the magnitude of vector v to the nearest tenth? Mark your answer using the grid provided. What we use is essentially here a version of the distance formula. The distance formula is the square root of quantity x2 minus x1 squared plus the square root of quantity y2 minus y1 squared. And what these happen to be, if you use the head minus tail method, is this 6 is going to go right here for the change in x, and this -3 is going to go right in here. So what we are left with is this. Our magnitude, which is our distance of the vector, is going to be, we have 6 squared plus -3 squared. Now, mistakes sometimes people will make is they'll think that this -3 squared could be negative. It'll end up being -9. No. These things in here, these numbers, are going to be positive. So 6 squared is 36, and -3 squared is 9. So we are looking for square root of 45. And we are going to enter a grid here, so we need to have that decimalized. So if we go to our calculator, I'm going to press Control I, add calculator. We're going to put in square root of 45, and that's going to be to the nearest tenth, 6.7. Okay, so 6.7. So we go up here to our gridable area, so we put in 6.7. And we could put 6.7 anywhere in these cells, just as long as they're consecutively entered properly. So we have 6.7. Okay, and the 08, I mean, if you enter the 08, which you could, I guess that'll still automatically give you correctly, but it's not really. Technically, you're supposed to put the nearest tenth, which is the next digit after the decimal place. Okay, last problem is 14. What is the measure of side M of the triangle LMN shown? Now, that's like one of the problems we did earlier. I think it was problem 6, if I'm not mistaken. Well, that's going to be M squared equals 57 squared plus 29 squared minus 2 times 57 times 29 times cosine of 119 degrees. And we go to our calculator and we go to menu 3-1. We're going to put in M squared. So we have M squared equals, looks like 57 squared plus 29 squared minus 2 times 57 times 29 times cosine of 119 degrees. And so we put in comma M if we're solving for unknown M, and we have this. which is 75.45, and I think it's the nearest tenth, so I think it'd be 75.5. Let's go ahead and put that in place. It's not 75.45, even though that's what the calculator said. Round up. So we put in 75.5. Go enter 75. 0.5. Again, this defaults positive, so we don't really need to mark this positive. No, we can do that. Anyway, that's it. It should have been a pretty easy test. It really is kind of basic summary of the things we've gone over the 6-week term. And good luck in your future studies. Thanks for viewing.